Salam all. This is a really deep question, so I'll try to answer as efficiently as possible. It all really has to do with relative motion or how motion is being perceived by an observer. If the observer changes, then so does the perception of the motion, if that makes any sense. And what I mean by that is that if you look at the flight path of an airplane, some maps will show you that that path was curved from one location to the next, and other maps will show you that it was a straight line from one location to the next. Both of them depict an accurate image. It just depends on the framework that they're claiming that image from. And so in some maps, it might make sense to show that as a straight line. In other maps, it might make sense to show that as a curve. Well, a free-falling object works the same way. You have the 3D lens and you have the 4D lens. In the 3D lens, from what we can see observationally, it makes sense to say that the path of a falling object is downwards. Now, in a four-dimensional sense, where we're talking about space-time, it doesn't make sense to say that it is downwards because nothing that is considered matter moves or is subject to any kind of downwards fall. Space-time is curved, so anything in that space-time would also be subject to that curvature. Now, a deeper question is, why is it curved? Well, it's curved because mass distorts that space-time continuum. If you think about the fabric of space-time as a sheet of paper, if I were to put this horizontally and then place a mass on it, it would probably curve something like that, right? All around that heavy mass. Well, stuff like planets, suns, anything with a significant amount of mass is going to curve the fabric of space-time. And so any object that is in free fall is subject to that space-time curvature. And so given that this is what the fabric of space-time kind of looks like, it doesn't make sense to really say that an object moving through this is going up or down. It's really just moving along the curve. And that's called a geodesic. And a geodesic really just describes the shortest possible distance between one point and another point on a curved surface. So to sum it all up here, an object or a mass will tell time and space how to curve. And once that time and space has been curved by that mass, that time-space curvature tells that mass and anything inside that fold how to actually move, including free-falling objects.